Okay, please, this normal distribution is a very technical thing to So if you are hearing for the first time, probably you are not even you are not exposed to this kind of question. It can look somehow complex and technical. So I would like you to listen attentively and carefully. All right, let's go. Like I said the other time, this is a distribution. It's a normal distribution. It has a this kind of shape like this, goes up like that and come down like this. Now at the middle, so at the middle here, this is the mean. And look at what they wrote there. The mean, the median, and the mode are all nearly equal, so they are almost equal here. But at least let me use the mean as an example. This is the mean of the distribution. Now remember what I told you about standard deviation and the relationship between it. I told you that when the standard deviation is higher, the data spread out. It spread out from the middle, of the distribution. So, and this is what is happening here. It means that it's moving away from the, but when it's coming together, if the standard deviation is close, it's moved closer to the middle. So it is the mean here. Now look up. Um, this is a good way to explain that. Now look at, let's say this is the mean. From here to this place, that's a distance. It's one standard deviation. From here to here, it's another one standard deviation to the left. And from here to here is another one standard deviation. That's three standard deviation. So one standard deviation, two standard deviation, three standard deviation. The reason why they are putting negative here is just to show that it's going to the negative side. And to the right side there, see, this is the middle. The middle point. Now from here to here is another one standard deviation, which is one. Another one to this next one is two standard deviation. To the last one, the third standard deviation. So it's just to show you the spread out. It's going to spread out like that. So the reason why this is positive is because it's going to the right direction. But the reason why the negative sign is here because it's to the negative side of it. So I'm going to show you more. Now the same thing happens here. So this m, the middle number or the mean. As you said, they're actually equal. And here we're talking about number distributions. So like this, like this again, right? So you can have a graph that has like three standard deviation. If the middle is going to always, this, for example, the mean for this distribution will be 20. The mean for this one, let me check. Maybe around here, I have 0 point something, I'm not sure. The mean for this place should be minus 10. So to the left, to the right. So from here to this side, that's based on the way you draw the diagram. So I don't want it to be more complex than that. So this is another diagram. I just tell you that this is the middle. From here to here is one standard deviation. Look at the line. You follow the line. It's drawn in the shape. It's one standard deviation from here to here. Another standard deviation like that. So that's to the left, to the right, the same thing. You just try to cope with the diagram. You have to understand it. Now you can't really appreciate this until I use until I use an example to show you what I mean. So please, when you read through this, you get to understand better. Now let me show you what I wanted to show you about that. Now this is similar to what I just showed you, but this one is the labeled one. I've been showing you a lot of graph recently. So this is a labeled one. See, this middle here is the mean. That's m. From here to here is one standard deviation, but to the left, that's why we have a negative value. From here to here is another standard deviation, that's 2d. Another one, then to the last one, 3d. To the right side, 1d, following on 2d. So just the show of spread out. Now, if this value comes together like this, if the diagram is close together, in this case, let me show you. Like in this case, see, I'm going to draw the line. You see the data are close together here. So it means that the data is moving closer to the mean. right? And that means standard deviation will be what? Will be small. Because the standard deviation is just showing you the spread, how spread it is. The spread out from the mean. This is spread out. Spread out. So but when we have something like this, it means that it's coming together. So that means the closer the smaller the standard deviation, the closer the data to the mean. And when it's spread out like this, so the higher when the standard deviation for this middle diagram is going to be very large. So it means that the data will spread out from the middle one. Well, let me just show you the labeling. So now well, the one I normally use is just 34%, 34%. I don't use, this one is close. 30, this one they use 34.1%. Look at this diagram. This is the middle, right? So this one are the same. This blue one are the same. So 34.1%, 34.1%. But for me, I use 34. 34. I prefer that one to this 31.1. But let me just show you the labeling. So the next one is 13.6. For me, I use 14 for this side. And look at this side, 13.6. But for me, I use 14. And this next one is going to be the label to be 2.1%. And this one to be 1.1. Look at the 2.1. So what happens here must happen on the other side. So this is just labeling. I'm just showing you how it is labeled. But my own is not labeled like this, it's just very close to this. My own, for example, my own I use 34, 34, 14, 14, I use 2. I use 2 too. That's what I want to show you. Now let me show you one of a question that you need to use this knowledge to solve. That I believe you should have encountered in this book. I'm going to take you to the place, and if I'm sure that question should have been one of the questions, is that you have told me to that it's difficult. You have told me at a point that probably you don't know how to solve it, or maybe you just kept it. But I know it's going to be very difficult to solve. So I'm going to use this to solve this right now, and just give me a minute to go to that page. So this is an example of the question we use what I just explained to you now to solve. Look at the question. The random variable x is normally distributed. Normally distributed means that it has a bell shape like that, shape like this. You get the value 650 and 850 are at 60th and 90th percentile of the distribution of x now respectively. And I said the value at 75 percentile of the distribution of x and 750. So this kind of question, these are the one that you pick the highest one. If quantity is higher, you pick A. If quantity B is higher, you pick B. If they are the same, you pick C. And if none of them, if the question is not correct, you pick D. So let's try and solve it. Look at the question well. Let me show you my own sheet. Now, since they say it is normally distributed, so this is the diagram. You draw it yourself. Like I've drawn I don't mind my diagram. I have to use my hand to draw it so you can understand. Now, this is my labeling. This is the middle, 0, right? Draw will be very important. And draw the lines. Draw one line here. Draw one line here. So that's one standard deviation. From here to here is one standard deviation. From here to here is one standard deviation. But this one is to the negative side. That's why I put minus. So this side is positive. That's why I put 1. Now from here to you draw another 1. That gives you the second standard deviation. So that's another. I drew it like that, and that's all for me. For this last part, you balance it up here to draw this line here. So that will be -2. So 2 standard deviation away from the mean. So we're just doing this relative to the mean. Now let me now label 34%. I told you the other time I prefer to use this labeling. 34%, then 14%, 14%, 2%, 2%. Now you are supposed to learn how to draw this diagram yourself and learn how to label it yourself. Nobody will teach you this when you want to use it. For example, if you take the question, they didn't tell me it's just a question, so I have to be the one because I know the kind of question. I know how to label it, so that's why I label it this way. So you should know this yourself too. Now, this 2%, 2%, 14%, 35%. So the logic is if you add this half, this is supposed to be 50 because it's in the middle, right? 50%. So if you add this other percent, it must be 50. 2 plus 14, that's 16. 16 plus 34, that's 50. So it must be like 50. This other part too must be 50. 50 if you add it together. So that's the logic. Now, the question is asking that between this and this, which one is higher? Now, you said the value at, okay, wait, before that, let's label it completely. 650, right? 650. Let's locate 650 and 850. 650 is at 60 percentile. Abi 650, 60 percentile. Let's go back. This 650 here. This 50, right? So we need 10 more percent. Let's just use our brain. Because this is like from here to here. Let's look at it. So 50 to this is 84. We should add 34 plus 50 is going to give you 84. That's why you have 84 here. Now we want to add just 10 more percent more to 50 to look at us, because that's how we can have 60, right? This is 60, right? Now let's say we have 60 here, and now we have 650 around here. This is where you're going to have our 10%, 60% here. Now let's look at for our let's check the other one. Talking about 90 percentile, we have our 850 there. So let's check. So 90. So you know that this is 84. So we need our 90. This is 98. 98. 84. How do you get all this? You add these values. For example, you add this 84. How do you get 84? 34 plus 50 is 84. Then to get our 90, 14 plus 84 gives us 98. Right? So you need the 90 in between this place and this place, So we need to add just 6% to this 84 to give us 90, So 6 and 8. Let's just look at it like so. 6 and 8. So if you 6% more, so if you add 6%, if you look at it, 6 and 8, so this is where you're going to locate your 90 degrees. So that's why we have 850 here. Now the question is now asking that let's locate 75% on the diagram. Now look at this 60, so sorry, this is 50. This 50, and this no, let's do it this way. This 60. Let's say this 60 because look at that 60 to be 650, right? 75 will now be around between 60. So we just need 10 more to this because this is 60. So let's look at the space here. Let's have another space here to be around here. That 10%. So we have our 75 to be here. So okay, sorry, 60, 70 should be around here. So we had, since we are looking for 75, just 5 more percent should be around here. So that is 75%. Now there's no way to calculate. You have to look at it and use your brain tactics. So 75% will be around here. That's the location. Then our 750. Now since we have our 650 here, we have our 850 here. 850 here, so if you look for the average of 65 and 85, it's going to give you 750. So we are going to locate the middle of this 650 and 850. And if you look at it like that, it should be around here. Around here. Because this is 850, this is 650. If you add 650 and 850 together, you look for the average, you get 750. So 750 will be in the middle of 650 and 850. That's around it. So that's what we have it. Now, if you look at it on the graph, it means that 750 is more than 75%, and that's why B is the answer. If you check through B is the answer. So that's the answer. And this is quite technical and stuff, but just take your time and read through it. Thank you. Key things I think